Hey everyone, today we're going to discuss about the truth table of a conditional proposition. In our previous video, we've learned what the truth values of compound propositions. Now this time we're going to deal with two other propositions, the conditional proposition and the biconditional proposition. So for the conditional proposition, P implies Q, or if P then Q, if the antecedent is true, then the consequent must also be true. So the scenario here is that if the antecedent is true, then Q, the consequent, must be true. If this is true and the consequent is false, then the entire statement is false. However, if the antecedent is false, it doesn't matter if the consequent is true or false. Now, let's try to have a truth value for the conditional. Let's say that P is true, true, false, false, and Q is true, false, true, false. For the conditional proposition, if P is true and Q is true, then the statement is true since the antecedent is true and the consequent is also true. However, if the antecedent is true but the consequent is false, then the conditional proposition becomes false. However, if the antecedent is false, it doesn't matter if Q is true or false. The conditional proposition will still be true. The only time where the conditional proposition becomes false is that when the antecedent is true, yet the consequence becomes false. Now for our second one, we have the biconditional proposition. For the biconditional proposition, if the antecedent is true, then the consequent must also be true. And if the antecedent is false, then the consequent must also be false. It goes both ways. Remember that the biconditional implies that if P implies Q and Q implies P, it goes both ways. So for the truth value of P if and only if Q, we have this one. If the antecedent is true and the consequent is true, then the biconditional is true. But if P is true and Q is false, then the biconditional is false. If P is false and Q is true, then the biconditional still remains false, because if the antecedent is false, then the consequent must also be false, which didn't happen in this row. For the last one, if P is false and then Q is false, then P if and only if Q would be true. So this is our truth value. Both P and Q must be true for the biconditional to be true, or P and Q must be false for the biconditional to be false. If they're different, like in these scenarios, then the biconditional becomes false. But for the conditional proposition, true, false makes it false. Otherwise, it doesn't make it false. It remains true. Okay, let's have an example here. Let's try this. P and Q implies not Q. So let's determine the truth value of this statement here. Let's start first by having the P and Q. So let's have P as true, true, false, false, and Q as true, false, true, false. So let's have our first statement here. Let's try to determine first what P and Q is. Then let's have not Q. Once we have those two, let's use the conditional statement on those two statements. So let's have the first statement, P and Q. So let's have P and Q. So this becomes true, true is true, true, false, 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 true, false, and false, false, false. So that's for the truth value for end. Let's now have not Q. So if Q is true, not Q is false. If Q is false, it is true. So that's our condition. That's our truth value for the not Q. And lastly, since we have P and Q, our first statement, and our not Q, which is our second statement, let's combine them together as P and Q. Let's put a parenthesis here. Implies, so let's put an arrow. Not Q. So let's have that one. P and Q implies not Q. So there we have that. So true false is false, false true is true, false false is true, and false true is true. So this is the truth value of P and Q implies not Q. So that's it for the truth values or the truth table of the conditional proposition. Hope you guys learned a lot today. Thank you guys for watching and see you guys on the next video.